Alright, so here's a review answer key. First thing, if the parent is 2 to the x, then describe all the transformations going on. So I'll kind of do it one at a time. This minus sign right here will flip upside down. That'll flip the whole graph upside down. The 5 will vertically stretch by 5. This plus 1 up here is with the x, so it's a left to right shift, and it always lies to you. So it will shift left 1 unit. And the plus 9 at the back is your up or down shift, and it does not lie. So it's shift up 9. So those are the 4 moves going on there with all the transformations. The second one is one you'd graph and then analyze it. So here's a picture of it, right? I just typed it into y equals 5 times 1/2 to the x. We look at the graph, it kind of looks like this. So my domain is always negative infinity to infinity. We're all real numbers. The range is the y values, so this graph does go up forever, but it does not go down forever. Its asymptote is the x-axis, so that would be y's from 0 to infinity. Increasing or decreasing, the whole time it's going downhill, so that's a decreasing one. The y-intercept, if you can't tell, you could look at the table, but it's at 5. You could go to your graph, or you could type in a 0 for x, that always works. And I guess it's 0, 5. And then the horizontal asymptote is the x-axis, but we write it as an equation because it's a line, that's y equals 0. So that's breaking it down for all those parts you need. Alright, moving on to these. This is when you're switching from exponential to log form. So if it's in log, you want to switch to exponential. So this is where you do the swoop, right? Swoop's pretty easy. You just grab that 5 and you bring it over here and bump that 2 up. So it's 5 to the second equals 25, which is not news to anyone. Same deal here. This 2 goes over here. 2 to the negative 1 equals 1/2. And then the reverse over here, I always like to take the base, so there's the 3, and then I put the exponent on the other side, and then the 27, the answer goes right there. You can always do the swoop to check if you did it right, if you're ever doubting yourself in that. Same with this one. So I'm going to go log, I'm going to steal the base, then I make the exponent go over here, and then I put what's left over right there. Alright, moving on. So now we're solving for x. You just got to remember, to undo an exponent, you use a log. Alright, so we're going to log both sides. I'll do a mixture here, so we'll maybe common log this guy, common log that guy. Oh, these are all related. That's weird. Okay, I didn't have to do it this way. There's more than one way to do this. And then divide. You'll get a nice answer because I should have noticed that if you type that in, common log of 64 divided by common log of 4, get a nice answer of 3, and I should have noticed that because I can rewrite 64 as 4 to the third. Same with this one. If you ever notice, by the way, I could common log both sides and I'd be done. Or if I want to, I can rewrite this as 10 to the negative third, and then I know my answer, because if 10 to the x is 10 to the negative third, they must equal each other. This one's really easy because I guess all you had to know was e is just e to the first power, so x must be 1. Your other option is natural log both sides, and you'll still get x equals 1. So, alright, this one's a little harder to do in your head. You'd be like, how can I rewrite that? Oops, as 8 to a power. Well, anything to the 0 power is 1. But if you didn't know that, you could still just log both sides, drop that out, and x is going to be common log of 1 over common log of 8, which is still 0. Any way you slice it, you're getting 0 for that. Same here. You could log both sides, or you could notice that this is 2 to the, well, if I think about it, how do I make a 16 is 2 to the 4th, since it's in the bottom, negative 4th. Once again, if you didn't notice that, you could just log both sides. Alright, and this one is write it as a common log. So here you're doing that change of base formula, where it equals common log of the top over common log of the bottom. And we'll type that in our calculator. Same deal with this one. The thing you got to remember is the one that's in the basement goes to the bottom. Right? The base goes to the basement. So I could use natural log here too, but I don't want to. Just because I don't. Alright, so yeah, you just type those in. Common log of 13 divided by common log of 6. Make sure you end your parentheses on that. Otherwise you'll type it in wrong. And you do want to be able to round correctly because, this is Algebra 2. You've rounded for a few years now. We gotta be cool with rounding. Alright, and then divide by log of 4. Boom. We get 0.904. Alright, cruising along, right? Here we go. To the back. Alright, the back, we got these rules here. Those are your 3 rules. And you can use them to expand or condense. So when it says a single logarithm, you already know there's just going to be one log in the end. So I usually take those exponents and put them up top. So we'll have log base 2 of 12 squared minus log base 2 of 6 squared. And then I know, okay, the minus sign turns into division inside a single log. So we'll have a single log of 12 squared over 6 squared, which turns into a single log. And then 12 squared is 144 divided by 36 is going to be single log of 4. Now this you can actually evaluate. And it says to do that. That means it's going to be one you know in your head. Remember, logs ask a question about the powers. So you'd say 2 to what power is 4? That's what that means. And 2 to the second power. Okay, you could type that in to confirm. Alright, hold on. Okay, our next one. Once again, I take care of those first. So I'd rewrite it as common log of 100 plus common log of 10 squared, which is really 100 again, right? And then a plus sign means I multiply what's inside. So it becomes a single common log of 100 times 10 squared, which is really that 10,000. And then common log is base 10. It's not written there, but you know it's there. So really, 10 to what power is 10,000? And that would be the 4th power. So your answer is just 4. Not 10 to the 4th, but just 4. Okay, now we're going to do these in reverse. Here we're going to use our properties to expand them. So we're like going that way, making them bigger. So first I notice there's a multiplication in here. And if the problem starts off with log base 6, you just keep it going. You just play follow the leader. So since it's multiplication, I turn it into addition of 2 logs. And then I have that rule that's very handy, where if you have a power, you bring it out. So that's 20 log base 6 of u plus 5 log base 6 of v. And you can always check if you did it right by condensing it and seeing if you get back up there. Same with these problems. You could expand them. That one's harder, but alright. So this one too, you follow the leader. So when I see division, I'm going to think subtraction. So natural log of x minus natural log of y to the 4th. And then I can bring that 4 out. Always remember the thing on the bottom goes after the minus sign. There it is. Just using those rules. Okay, now we're solving. In this whole section, we're solving exponentials. So you solve exponentials with logs. Now here I could use common log, or I could use log base 4. On this problem, I kind of want to use log base 4, and you'll see why. It just makes it pretty. Oops, that's an equal sign. So log base 4 to the left, log base 4 to the right. What's cool about this is a log base 4 kills an exponent base 4, and you're just left with 2x plus 3. I don't have to do anything more with that. And then I'm 2 steps away, subtract 3, and then divide by 2. So, actually, if you have log base 4 of 1, I'm going to do it this way. You could do this with change of base formula too, but I'll just show you could type it in like that. It's 0. So 0 minus 3 is negative 3. Divide by 2, and you get negative 1.5. All right, same deal here. Don't do logs until you get the exponent by itself. So it would be a mistake to take logs right away. So now that it's by itself, I can log both sides. And since it's an e, you'll see me do a natural log of both sides. Okay, natural log will kill the e, and you'll be left with x minus 1. And then add 1 to both sides. So my answer is whatever natural log of 10 plus 1 is. Make sure you don't put it in the parentheses with it. You just do natural log of 10 first, then plus 1. 3.303 is your answer there. All right, keep on keeping on. We're getting there. This one, log base 4 both sides. 4 to the 4 minus 5x. And that'll actually turn into a nice answer, I think. I'm going to type that in and see. So if I type that in, you get a 4, because 4 to the 4th is 256. Now I'm 2 steps away, take away 4, and x is 0. You can always plug these in to check your answers, and you'll see if you're right or not. All right, this problem, it's not by itself yet, so I need to divide by 2. 128 divided by 2. It's going to be a nice one too, 64. You could notice that that's 4 to the 3rd, or you could just log both sides. I could do log base 4 also, but I kind of want to do it a different way this time. Common log of 4, and then common log of 64. Divide both sides, and then we'll have x plus 2 equals 3. And then, because when you type that in, you'll get a 3. And then you take away 2, and x equals 1. All right, so now on to the last chunk of problems, and that is undoing logs. So kind of like before, the first step is to get it by itself. And then I undo a log base 2 by raising it into a power of 2. Or you could do the swoop if that helps your brain. 2 to the 5th. That's 32. So here you have 32, and then take away 2. X is 30. All right. This is a nice problem. If you ever notice you have same log on both sides and there's just a single log, you get to just cross them out. That's cool. Then it's just an algebra problem. I'm going to pause and do that. Alright, so there's the answer to that one. You can pause it. The next problem, you have to do a little work to get the natural log by itself, but once you do, you just have to raise both sides to the power of e. And e to the negative 4/3 is 0.264. Alright, then our last problem, we have to condense those using multiplication. You get it by itself, you put them both in the power of 5. Then when you factor this, you get two answers, but